Hi, my name is Isabella, and today I'm going to be going over the CoreData stack in Swift. To do this, I will be using this open source app called Expense Tracker, which is used to track the daily expenses of a user. So here is a brief overview of the GitHub page and how it looks like. In the README, you'll see a couple of screenshots. This app has two main tabs. One is the dashboard tab, which shows you an aggregation of all of your daily expenses, broken down by category. And the second tab, called Logs, shows you a list of your expenses, which you can filter using the search bar, or using categories, or sort it in ascending or descending order by date, or by amount of expenses, or just ascending or descending. And this is also the same tab where you can add a new expense and save it. So CoreData itself is a framework in Swift to save, track, and filter data within iOS apps. And given that Expense Tracker tracks user expense data, it is fundamental to the way the app is able to function. So I will be running over the code and documentation today to demonstrate how all of this works. If you look at this more closely, you see that CoreData is really good just for cutting down on code, and for a couple of properties. One is persistence, so being able to map your objects to a store and save the data without having to administer an actual database. You're also able to edit your data once it's entered into the database. You can delete it, you can undo it, and you can also do background data tasks. So let's move into the code. So this is the code for Expense Tracker. And when working with CoreData, you'll first have to create a CoreData model. Here you'll find it as the following file, Expense Tracker with the following extension. And in this, when you click on it, you'll see the entity called expense log. This describes an object, including its name, attributes, and relationships. And this will be used to store all the details of a single expense. So here we have a list of the attributes. We have amount, category, date, ID, and name. And every single expense is assigned all of these attributes in what you would imagine as one row entry in the database. So once you have your CoreData model file, we'll move on to all the other classes that support it. So back to the documentation, you'll see that this is collectively referred to as the CoreData stack, which is housed under the models directory as CoreDataStack.swift. So here in the documentation, we have NS persistent container. Once you create this essentially encapsulates the entire stack, and it sets up the model, the context, and store coordinator all at once. Here on the left, the NS managed object model is the model, and this represents your app's model file describing your app's types, properties, and relationships. Here, an instance of NS managed object context is the context that tracks changes to instances of your app's types. And here, an instance of the NS persistent store coordinator saves and fetches instances of your app's types from stores. So let's head back to the code. So now that we've created our model, let's look at the CoreData stack.swift. So in here, we have the persistent container setup as a lazy variable of the type NS persistent container. We also give the entire container a name. Once created, this persistent container holds references to the model, the context, and store coordinator instances in its managed object model, the view context, and the persistent store coordinator properties respectively. If you scroll down, you also see that the developer added an extension to the NS managed object context, and this is an ability to improve the performance by saving the context only when there are changes. There's also another model that's being used. It's called expense log plus extension, and what this does is that it adds on to the expense log in two main ways. We have first the fetch all categories total amount sum, which is a function that basically fetches all of your expenses using NSFetch request, and it indicates the entity attributes to fetch. So here we have category and amount, and it computes the total expenses. Here you see that what it does is that it maps the expenses to different categories, and we use the categories as keys. The other function that this model does is that it adds a predicate, and this is another really useful function of the CoreData stack. So this function allows you to filter your data results by adding an NS predicate object over here, and you add it to the fetch request in order to narrow down the number of objects being returned. Here we are filtering by category in your search text, and you see in the simulator under logs that this is where you can search different labels in the search box, or you can filter according to these different categories. So this is where it's set up and processed as predicates, and you'll add this to your fetch request eventually, so that you can display the list according to your filter requirements. So now that we have all of the fundamental components of the model, let's see how all of this comes together to make the app work. So here we have our log form view, which manages the form to create an expense. First, we declare an instance of the expense log to manage one expense, and we also have ns managed object context for the context that is supposed to contain all of the user's expenses. So here we have the form and all of its fields. We have one each for name, amount, category, and date. And once we enter the data and we click save, you'll see that the code records all the details of these expenses for storage. Here we have expense log, and what it does when you click save is that it assigns the name, category, amount, and date to the log, and then it saves this to the context or prints an error otherwise. We also have the option of editing what's already stored, and you'll see this over here. So if you've already put in an expense into the app and you would like to change one of its attributes, here is where it's processed, so it'll just replace what that particular entry attributes have with your new attribute values. So next we have log list view. So this is, again in the simulator, the list of all the expenses that are displayed. By default, it shows you all of your expenses without any filters. But as we mentioned just now, we have the use of ns predicate, which gives us an ability to filter this according to different criteria. So again, we initialize at the very top the ns managed object context because it's the same context. And we have fetch request here, which is a property wrapper type that makes fetch requests and retrieves the results from a CoreData store, which we sort by date using the ns sort descriptor. So over here we have our fetch request, and if we do have some predicates that we want to sort the data by, we assign this to the fetch request before fetching, and we put all of this into a result. We also have the option to sort the data, and that's covered in the sort model, which is over here. It's pretty basic. It allows you to sort ascending or descending, sort by date or amount, and all of that is pretty straightforward. We also have the logs tab view, which isn't too concerned with CoreData. This is essentially some higher level displaying of how you want the results that are fetched, and all of this is done within the CoreData ns managed object context. So now that we've covered the bulk of the logs tab, we'll move on to the dashboard tab. So if you remember, this is, as we can see on the left, an aggregation of your total expenses as well as a breakdown of your expenses total by category. So this is all contained in the dashboard tab view. Back in the expense log plus extension model, we had the function fetch all categories total amount sum, which totaled the sum of expenses recorded. So we call this in the function over here called fetch total sums. You see it here, which essentially totals your expenses and also totals it by category. So this assigns it to self. And again, we have a mapping so that you can match your total expenses by category and then display it. So that's pretty much the extent to which CoreData is used in this app. To recap, we created a CoreData model. We supported it with the NS persistent container, which encapsulates the entire stack. And we use the model, the context, and the store coordinator in the code to enter, store, and retrieve data throughout the app. I hope this was helpful, and thanks for listening.